radical equations with a focus on square roots. We're going to start with a single radical. And the approach that we're going to use is we're going to get the radical to one side of the equation and everything else to the other side. After we do that, we're going to square both sides of the equation and then solve the resulting equation, being sure to check our solution in the original equation because sometimes by squaring, we'll wind up with a false solution. All right, so let's look at the first example. Here I have the square root of x minus 5 plus 4 equals 7. I want to get the radical to one side of the equation by itself and everything else to the other. In order to do that here, I'm just going to subtract 4 over to the right-hand side. This is going to give me the square root of x minus 5 on the left-hand side, and it's going to give me a 3 on the right-hand side. Now, I'm going to square both sides of my equation. So it's going to be kind of like this. I'm going to square the square root of x minus 5, and I'm also going to square the 3. Okay. Now, if I square the square root, that essentially just cancels itself out. So I'm just left with x minus 5 on the left-hand side, and then 3 squared on the right-hand side turns into a 9. All right, now we're going to solve this resulting equation. To do that, I'm going to add 5 over to the right-hand side so that I get 9 plus 5 is 14. All right, now we have to be careful here. We have to check our solution. Came up with one solution here of x equals 14. Let's check it just to be sure. So I'm going to check it in green. So I'm going to plug it into the original equation. I'm going to have 14 minus 5 underneath the square root. Then I'm going to add to that 4 and see if it indeed does equal 7. Well, 14 minus 5, that's 9. So I'm looking at the square root of 9 plus 4. I need to check and see if that equals 7. Well, the square root of 9 is 3. 3 plus 4 does equal 7 because 7 equals 7. Awesome. Good to go there. So our resulting solution here does in fact work. So x equals 14 is a solution to this equation. Let's try another one. All right, example 2. Here we have the square root of x minus 3 minus x equals 5. Okay, we want to get the square root by itself on the left-hand side. Okay, so what I'm going to do here is I'm going to add the x over to the right-hand side. And I'm going to rewrite it like this. I'm going to rewrite it as the square root of x minus 3 equals x plus 5. I like to put the x before the 5 personally. Now, I'm going to square both sides of this equation. So I'm going to square the left-hand side, and I'm going to square the right-hand side. Now, what this is going to give me is it's going to give me an x minus 3 on the left-hand side because the square root and the square are going to cancel each other out. But this part of the equation is x plus 5 squared. And we know that x plus 5 squared is the same thing as x plus 5 times x plus 5. So we need to go ahead and FOIL that out. All right, so we're going to do x times x is x squared. X times 5 is 5x. And 5 times x is 5x, resulting in a 10x in the interior. And then 5 times 5 is 25. If you need to take an extra step, especially for that intermediate middle value there, by all means, write your extra step of FOILing out if you need to. All right, now let's continue to simplify here. I need to get everything all on one side, so I think I'm going to take everything over here to the right-hand side. So I'm going to subtract an x over, and I'm going to add the 3 over. All right, so this is going to give me a 0 on the left-hand side. Oh, where did my... There it is. It's going to give me a 0 on the left-hand side because I subtracted everything over that was on the left-hand side. It's going to give me an x squared plus 9x plus 28 on the right-hand side. Now I can try to factor this. Let's see if we can factor this. Okay. And remember, if you can't figure the factoring out, just do the quadratic equation. No shame in that. You will get the correct answers if you force your way through the quadratic equation. But here we have a 28. Do I have two factors of 28 that'll multiply to give me 28, but add to give me 9? Let's see. Now, if you're thinking like I am, you're like, 28. Factors of 28 are 1 and 28, 2 and 14, and 7 and 4. But none of those give you 9. I don't think we can factor this one, ladies and gentlemen. Let's try that quadratic equation. I know we hate to do it. But let's look at the negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's see what that gives us. Well, negative b here is negative 9 plus or minus the square root of b squared. So we're looking at 9 squared minus 4 times a, which is 1, times c, which is 28, all over 2 times a, which is 1. I see what's going to happen here. Maybe you do too. We have a 9 squared that's 81, and then we have a 4 times 28, which I think is 112. So we're going to wind up in a negative square root situation. It's okay. Let's work through it. Okay, this is going to give us the negative 9 plus or minus, like I said, 81 minus 112 all over 2, which simplifies down to negative 9 plus or minus, let's see, 81 minus 112, I think gives us negative 31 all over 2. So we do wind up with solutions here, but if we write them appropriately, they're imaginary or complex solutions. So here I have negative 9 plus or minus, that's an I square root 31 all over 2. So it is possible here to get imaginary solutions. If it asks you if there are any real solutions, there are no real solutions to this particular case. There are only imaginary solutions to this case. A lot of times we want real solutions. So if it's asking for real solutions, you'll have to say it has no real solutions. But if it allows you to input imaginary solutions or complex solutions, you have 2 of them for this particular case. All right, let's look at the next one. Example 3. Here I have the square root of x plus 7 plus 6 equals 0. All right, let's get the square root by itself. So I'm looking at the square root of x plus 7 equals negative 6. All right, all I did was subtract this 6 over to the right-hand side. Now let's square both sides. Okay. Gonna get that done. That's gonna give us an x plus 7 on the left-hand side, and negative 6 squared is 36. Negative 6 times negative 6 is positive 36. Then we can subtract the 7, and we're going to get that x equals 29. Remember, though, we really have to check our solutions here. Okay, so let's plug this solution in and see if it works. Here I'm going to get a 29 plus 7 plus 6, and I need to check and see if that equals 0. All right, well, 29 plus 7, that is 36. Plus 6, does that equal 0? Well, the square root of 36 is 6. 6 plus 6 is not going to equal 0 because 12 is definitely not equal to 0. So this doesn't work. We got a solution that doesn't work. So we have no solution. It happens. That's why we have to check all our solutions, especially with these square roots. Now let's try a two radical approach. For a two radical approach, what we're going to do is we're going to get only one radical to one side of the equation and everything else on the other side, even if that means having a second radical on another side of the equation. Then we're going to square both sides and combine as many like terms as we can. After that, we will probably still have a radical hanging around, but we should only have one radical hanging around after that, so we can apply the approach for a single radical after we've applied the approach for that first radical, and then solve all the way through. So let's see what that looks like. So here I have the square root of 2x minus 5 minus the square root of x minus 3 minus 1 equals 0. Okay, we want to get only one radical to one side of the equation, everything else on the other. So what I'm going to wind up doing is getting this square root of x minus 3 and this 1 over to the right hand side by adding them over since they're subtracted here. Okay, so it's going to look like this. It's going to look like the square root of 2x minus 5 equals the square root of x minus 3 and then a plus 1 on the outside. Okay, now what we need to do is we need to square both sides. So I'm going to square the left hand side and the right hand side. Okay, now what that's going to do for me when I square both sides is it's going to cause that square root to go away on that left hand side, which is really nice. But on that right hand side, I'm squaring the square root of x minus 3 plus 1. Now, what that means is that I'm essentially taking the square root of x minus 3 plus 1 and multiplying it by the square root of x minus 3 plus 1. And we're going to have to follow our FOIL method, right? So we're going to multiply the first things first. And I'll do each step of this. So the square root of x minus 3 times the square root of x minus 3 is x minus 3. And I'll put it into parentheses just so that we can keep up with it. The second thing that I'm going to multiply is the square root of x minus 3 times 1. Well, that's just going to give me the square root of x minus 3 times 1. And then I'm going to multiply 1 times the square root of x minus 3. And then last but not least, I'll multiply 1 times 1. Okay? Now we can kind of combine the like terms as we need. And then after we do that, we'll be able to apply this last approach. But let's go ahead and combine as many like terms as we need. It's going to take a little space. Okay, the first like term that we can combine on the right hand side are these two middle terms, because the square root of x minus 3 times 1 is just the square root of x minus 3, and 1 times the square root of x minus 3 is just the square root of x minus 3. They're essentially the same term here in the middle, and we have two of them. So that middle term will simplify down to 2 square root x minus 3. Okay, and then we still have the plus 1 at the very end. Now let's continue to simplify. Now I have parentheses here, but they're really unnecessary at this point, so I can just drop those off so that I have x minus 3 plus 2 square root x minus 3 plus 1. Because now I can combine the negative 3 and the positive 1. So I'll get 2x minus 5 equals x plus 2 square root x minus 3 minus 2. Okay, now I really want to apply at this point the approach for the single radical, because now I'm down to a single radical, which means I need to get everything else to the left-hand side of the equation. So I'm going to subtract an x over and add a 2 over. So I'll subtract an x over and add the 2 over. Now this is going to give me x minus 3 on the left-hand side equals 2 square root x minus 3. Now before I can apply that single radical approach, I really need the radical to be completely by itself, which means I need to get rid of that 2 out front as well. So I'll go ahead and divide by it. Okay, so I'm going to divide by that 2 so that I get x minus 3 over 2 equals the square root of x minus 3. All right, we're getting somewhere. Now the approach for the single radical says that I should square both sides. And that's what I'm going to do. I'm going to square both the right-hand side and the left-hand side. And I'll stay in green so that we can differentiate our continued work here. Now if I square that left-hand side, right, it's going to be the same thing as x minus 3 squared over 2 squared. I'm going to apply the squared to both of those pieces. If I square that right-hand side where I have the square root of x minus 3, the square and the square root just cancel themselves out. So I'm just left with an x minus 3. Okay. Now, this will simplify. I need to go ahead and FOIL out this top part. And it should simplify to x squared minus 6x plus 9 all over 4 equals x minus 3. Okay. Now, what I'm going to do, I really don't like that 4 in the denominator, so I'm going to multiply it back over to the numerator on this right-hand side. So I'm just going to multiply this over to here. So it gives me an x squared minus 6x plus 9 equals 4 times x minus 3, which then simplifies to an x squared minus 6x plus 9 equals a 4x minus 12. Now I need to get all of my terms to one single side. So I'm going to subtract the 4x over and add the 12x, or add the 12. So I'm going to subtract the 4x over and I'm going to add the 12. So it gives me x squared minus 10x, and then 9 plus 12 gives me a 21 equals 0. Alright, so here's where I'm at. Now I'm going to have to use an additional slide for this. So I left off at 10 or x squared minus 10x, and then plus 21 equals 0. Okay. Now I think I can factor this one. So let's try to factor this one. I need two things that multiply to give me 21 and add to give me negative 10. Well, how about a negative 7 and a negative 3? Negative 7 plus negative 3 is negative 10, and negative 7 times negative 3 is a 21. All right, this means that x minus 7 has to equal 0, and x minus 3 also has to equal 0. Okay, well that means that x needs to equal 7 and x needs to equal 3. Those are our two solutions. But remember, life's just never that simple. We also have to check both of these solutions. Okay, so what are we checking them on? We're checking them on the original equation here. So we're checking them on the square root of 2x minus 5 minus the square root of x minus 3 minus 1 equals 0. So let's do this check step. I'm going to do it in red. I'm going to do the check step. We'll check first with x equals 7. Okay, so for x equals 7, that's the one we're going to check first. So I'll just plug 7 in for x and check. So it's 2 times 7 minus 5 underneath the first square root. It's 7 minus 3 underneath the second square root. And then we just have to simplify. 2 times 7 is 14. So I get 14 minus 5. 7 minus 3 is 4. So I'm looking at the square root of 4. And then a minus 1 here. 14 minus 5 is 9. So I'm looking at the square root of 9. The square root of 4 is 2. The square root of 9 is 3. And then negative 2 and negative 1 is a negative 3. 3 minus 3 is 0. So, hey, 7 does successfully work. All right, we've checked 7. Let's check 3. I'll change colors. For this one, I'll change it back to a blue. So I'm going to plug in for the 3. All right, so it'll be the square root of 2 times 3 minus 5 minus the square root of 3 minus 3 minus 1 equals 0. Okay, so here 2 times 3 is 6. Maybe look at 6 minus 5. 3 minus 3 is 0, and the square root of 0 is 0. So it'll be a minus 0 there, and then a minus 1. 6 minus 5 is 1, so I'm looking at the square root of 1 minus 1. Does that equal 0? Well, the square root of 1 is 1. 1 minus 1 does equal 0. So, hey, looks like our second solution also works. You have to check them all, though, because it doesn't always work out. All right, we've got one more to do. This one is the square root of 2x plus 1 plus the square root of 4x plus 9 equals 8. All right, same thing. I want to get a single square root on one side, move everything else to the other side so that I can then square. I'm going to keep the square root of 2x plus 1 on the left-hand side. I'm going to subtract over the square root of 4x plus 9 to the right-hand side. Then I'm going to square both sides so that I get 2x plus 1 equals 8 minus the square root of 4x plus 9 times 8 minus the square root of 4x plus 9 because it's squared. And then we're going to work on foiling it out. Okay. So I'm going to leave the left-hand side alone, the 2x plus 1. I'm going to FOIL out the right-hand side. 8 times 8 is 64. 8 times the negative square root of 4x plus 9. And then the negative square root of 4x plus 9 times 8 is the negative 8 square root 4x plus 9. And then the negative square root of 4x plus 9 times the negative square root of 4x plus 9 is positive 4x plus 9. Okay, let's continue to simplify here. I'm going to leave the 60, well, actually, take that back. I can go ahead and combine the 64 with the 9. If I combine the 64 with the 9, I get a 73. Okay. Then here, this will be negative 16 square root 4x plus 9. And then this will be plus 4x. Now I want to get the square root by itself. Okay. So I'm going to subtract over the 73. And I'm also going to subtract over the 4x. So that I wind up with negative 2x minus 72 equals negative 16 square root 4x plus 9. Okay, then I need to get rid of the negative 16 on the right hand side, so I'm going to divide it over. And then that should simplify down to x over 8. And then how about we look at 72 divided by 16? That should simplify down to, what is 8 go into both of those maybe? Yeah, so I think it simplifies down to 9 halves. Positive 9 halves equals the square root of 4x plus 9. Okay. Now, I'm going to square both sides. Okay. So, I'm going to square both sides. And I'm going to square this side. Now, I'm going to pause. I'm going to pause right here. Okay. And the reason that I'm going to pause here is because if I go about doing it this way, where I'm reducing this fraction and pulling this negative 16 over to the left-hand side, you're going to start getting kind of mad at me when we're having to FOIL out x over 8 times 9 over 2. Okay? And I get that. Trust me, I get that. So, what I'm going to do is change colors. We're going to go kind of into a kind of, you could go really 3 ways with this. You can continue with the way that we're doing. You can leave it just as it is here and square both sides. So you could square both sides from this side. Or because they're multiplied, what you can really do for a little algebraic tip here is you can leave it like this. So, and if you go ahead and square both sides anyway, even though you have that multiplication out front, what it's going to be is just negative 16 squared. And then this square root of 4x plus 9 is also going to get squared. Because they're multiplied, you can just distribute it to both. And what you find out here is this a little bit simpler sometimes. Not always, but sometimes to do it this way. Because then you could just FOIL your left-hand side. So I'm just going to go ahead and write it out like this so it's easier to FOIL. Negative 2x times negative 2x is going to be positive 4x squared, negative 2x, and negative 72. That's going to be 72 times 2, which is 144. You're going to have 2 of those for the middle term. So it's going to be positive 288x. And then negative 72 times negative 72 is going to wind up giving you 5,184. Okay, that would be your left-hand side. You can double check it if you want to. 16 squared or negative 16 squared is going to give you 256. So you're working with some kind of big whole numbers, but sometimes that's not the worst thing considering that you could have been working with fractions. And remember that the square root of 4x plus 9 squared is just 4x plus 9. And now you have some kind of big whole numbers. Sure. But let's see how it simplifies. Okay. So I need to distribute the 256 to both of these terms. So I'm going to leave the left-hand side alone for now. $256 times 4 gives you 1,024 x, and then 256 times 9 gives you 2,304. And as intimidating as that might look, you have a calculator, so it gets really simple. Let's get everything all to one side. So I'm going to subtract this over to the left-hand side. So that I get a simplification that looks like this. Okay, got to do a little math here. 288 minus 1024 gives me a negative 736x. And then the 5,184, if I divide or subtract 2,304 from it, I get a positive 2,880 equals 0. Okay, now I'm going to traverse that over to the other side here. So give me a second to do that. Okay, so I'm going to traverse this over to the next slide. That's 4x squared, and then minus, darn, squiggly pen gets away from me. Minus 736x plus 2,880 equals 0. Now, before you panic, what goes into both 4, 736, and 2,880? Well, how about 4? So what if I just divide this whole thing by 4? Okay, if I divide the first one by 4, that gives me an x squared. Easy. If I divide 736 by 4, that gives me negative 184. And then if I divide 2,880 by 4, that gives me 720. All right, got it a little bit simpler here. Just a little bit. Now, here's the next thing you have to ask yourself. Do I want to put this through the quadratic equation, or do I want to try to FOIL this? Now, this is a pre-calculus class. So if you're intimidated by the big numbers, you need to go back to your algebra class and get unintimidated, because we can do this. Let's go ahead and factor it. Okay. Luckily, this actually isn't too terrible of a factor here. I need two things that multiply to give me 720 and add to give me negative 184. Okay. All right. So, let's look at that. So, you can, like, if I'm looking at 720, okay, first two they'll look at maybe like 72 and 10. Those kind of jump out at you, but they don't really get you up to the 180, right? So I need something that gets me a little bit closer to the 180 range. What if I did, uh, what if I did like, what if I did maybe, remember it has to multiply to give you 720. What if I did say 180 and 4? That's the one that's kind of jumping out at me right now. If you multiply 180 times 4, you do get 720. Now, you might not have been able to see that straight off as much as I've done, because I've done a lot of factoring. So you might have had to try a couple exchanges in the 720 range. And really, it might be more helpful to just do it from singular numbers if I was laying it out. Like if I had no idea what this was and that 180 and 4 didn't jump out to me as quick as it did, first thing I look at is 1 and 720. Then I would look at 2, and then, let's see, 2, and then 360. Okay, now those clearly work. And then I could try 3. If I divide 720 by 3, I get 240. And then I would have gotten to the 4, and then 720 divided by 4 is 180. 180 and 4 give me 184, which is really what I want right there in the middle. So it does take a little guess and check work here, but you can figure it out. And like I always say, if you can't figure it out, just plug it in the quadratic equation. Anyways, I'm going to do x minus 180 and x minus 4. That gives me x times x is x squared, x times negative 4, and negative 180 times x give you the negative 184x, and then negative 180 times negative 4 give you the 720 that you need. This must mean that x minus 180 equals 0 and x minus 4 equals 0, which would tell me that x has to be 4 and x has to be 180. Okay, that's not bad, right? But we do need to check. Always the fun part, right? We do need to check. Okay. So let's do our check step here. I'm going to write it in red. We have to check the solutions. Okay. Let's do the 180 first. Okay. We need to put it back in the original. Alright, so we're looking at the square root. I'll just go ahead and rewrite it. The square root of 2x plus 1 plus the square root of 4x plus 9 equals 8. Okay, now we're going to check the 180 first. So I'm going to do the square root of 2 times 180 plus 1 plus the square root of 4 times 180 plus 9, and we're checking to see, does that equal 8? That's the question. We want to check and verify that that is the case. Well, 2 times 180 is 360. 360 plus 1 is 361. So I'm looking at the square root of 361. Okay. Plus, all right, 4 times 180 is 720 plus 9 is 729. So I'm looking at the square root of 729. Does that equal 8? Well, if I take the square root of 361, I get 19. Okay, if I take the square root of 729, I get 27. 19 plus 27 gives me 46. But 46 is not equal to 8. So unfortunately, this solution does not work. Oh man, it's a lot of work to get that solution. It happens. Let's check the other solution though. Let's check x equals 4. Alright, we're going to go the square root of 2 times 4 plus 1 plus the square root of 4 times 4 plus 9. And we want to know, does that equal 8? We want to verify it. Well, 2 times 4 is 8 plus 1 is 9. So I'm looking at the square root of 9 plus the square root 4 times 4 is 16. 16 plus 9 is 25. Does that equal 8? Okay, well, the square root of 9 is 3. The square root of 25 is 5. Does that equal 8? Well, yeah, it does equal 8 because 3 plus 5 is 8. So, our only solution for this one that works after checking is x equals 4. That is why it's important that you check your solutions. That completes this lecture. If you have any questions, let me know. Are there multiple ways that we can do several of these? Yes, we could have stuck with the fractions on this one. Like we could have continued on down from here using the fractions and squaring the fractions, and yeah, it would have been interesting and neat. I decided to go with just bigger whole numbers. That's why I transversed over here. But this algebraically was not incorrect. We could have stayed on this path, or we could have taken another path. What you'll learn is that in any style of these algebras and pre-algebras and calculuses and pre-calculus, a lot of times there's more than one method that will get you to the solution. You just have to find the method that works best for you, that you're able to work through the best. So if you have another method and it works, or if you decide to go down a different algebraic trail, but it eventually leads you to the answer, that's perfectly fine. Like I said, if you have any questions, reach out to me, let me know. Other than that, I'll see y'all next class.